So I don't have any indication about whether it's on the x-axis or on the y-axis. I only know that a squared and b squared are the same. They're equal, and I do not have what they're equal to. Okay, also, the hyperbola can be like this, or can be like this. How will I know eventually which one it is correct? Well, so from this, I have this information, right? And yes, I could write, I should. They are both the same. They're both A. But I don't know which one it is, if it's this or this. This point will tell me which one. Because if I get on this side a negative number that equals 1, not possible. So if I plug it in this form, and everything works okay, and I'm getting a positive number for a squared, then I know it's the case. That's the case. If I plug it in here, and I get a positive number for a squared, then that is the correct one. Which one would you like to try? It doesn't matter. We will know very easily. You want to, okay, which means, what will I plug in, and what does this mean? 25 over a squared minus 9 over a squared equals 1. I know I'm on the right track, because 25 minus 9 will be 16. So this is 16 over a squared equals 1. Two fractions are equal, and one of them is 1. So how much is a squared? 16. And I'm done. So it is x squared over 16 minus y squared over 16 equals 1. Let's see what happens if we plug it in the second one. Of course, it cannot work. If this one works, the other one cannot. So assuming we started with the second one, not with the first one, what will you write? You will write 9 over a squared minus 25 over x squared equals 1, and then you'll get stuck forever. Because you get negative 16 over a squared equals 1. Right. And a squared is a positive number. Yeah. So 16 over a positive number cannot equal 1 if I have a minus in front. Cool. So that's how I know for sure that it's not the case. So this is the correct equation, and the transverse axis is on the x-axis. Good pick. Any questions? Say it again? Yes, so this is the correct answer. Okay, last conic sections, and then we look at shifted conic sections, and that's the end of chapter 11. So 11.1, the parabola. So first, let's go back to the parabola that we know and see what else can we learn about it that we haven't discussed before. Well, there are a lot of things here that we haven't discussed about a parabola. So assuming there is a parabola with a vertex at the origin, and let's say this one opens upward. The vertex is the same. No change there. Same vertex as we know it from chapter 2. The parabola will have one focus right here. The coordinates of the focus are, in this case, 0, comma p. Again, by convention, we use p for the focus of the parabola. So then this distance is p. I will measure it on the other side of the vertex, and I will draw a line, which is a horizontal line.
So p is where? It's between the foci and the vertex?
0, comma p. So from the origin till this point, that's how we measure points, right? We plot points. So this is p. I will measure it on the other side of the vertex.
Okay.
And I would draw this line, which is y equals, can anyone tell us what does this mean? Y equals,
0, comma negative.
well, negative p, because it's the equation. Right, you just didn't look what I was writing. I saw that. Okay. This line is called the directrix of the parabola. And here is the interesting thing. That again, this is new. We have not discussed this before. Any point on the parabola, let's say this point, will be found at an equal distance between itself and the focus. My graph is not perfect, I apologize. And this. So this is a distance, it's perpendicular. So this blue line is identical with this blue line in measure. It's not in my graph. Sorry about that. I should have opened the parabola a little bit more. Sorry. So any point on the parabola satisfies the following condition. The distance between itself and the focus of the parabola and the distance between itself and the directrix of the parabola will always be the same. Now, I would like you to give me, I have not shown the equation of the parabola just yet, but I would like you to tell me, yes, this is the vertex, same vertex, right here, v 0, comma 0. What will be the coordinates of the focus of the parabola? F 0, comma p, right? And this one is still the same thing. Y equals negative p. Yes, you're right. Of course, p will be negative here, and this will be a positive number here. So this is still the directrix. Any point on the parabola will be found at the same distance. This must equal this. So any point A, if you want, on the parabola, will have to satisfy the distance between itself and F, and itself and the directrix be the same. Okay, in these two situations, it's the regular parabola that we are looking at. So it's x squared, right? So in both cases, x squared equals 4py. Yes, you can say, why don't you just write y equals x squared over 4p? Because it makes sense. However, we have to use this notation. We have to stick with this equation for a parabola going up and down, having a minimum or a maximum. And now, in the same way, you will give me the coordinates and the information for this parabola, which is not a function. The vertex is still 0, 0. There are no shifted just yet, no shifts. So this is the vertex. Can anyone give us the focus?
Negative p. P from 0.
P comma 0. Very good. Now, can anyone give us the directrix?
X equals negative.
Very good. Awesome. And now, what do you think the equation will look like? Not with x squared, but they will be reversed.
Yeah. Y squared equals 14x.
Very good. Indeed. And there is one more, of course. Same idea. Opening to the other side. Here's the last possibility. The vertex is the same, the focus, and of course, the directrix. And of course, the equation. Can anyone give us what we have to write?
Y squared equals negative 4px.
Still 4px, because p will be negative.
Oh, okay.
So f is p comma 0. I meant to write, yes, that's what I meant to write. And then x equals negative p.
On this last graph over here, x is still negative p.
Yes.
The directrix.
Yes, because this will be a negative number. So p is a negative number here, and minus p will be positive, so that's why this is x equals 5.
Yeah, so the equation is not really speaking to the sign of the
No, no. We are adopting,
Whatever this is P.
we are adopting the equation based on whether p is positive or negative. There is something called the focal diameter, which is this. The distance between this point and this point is called I should say the segment. It's called the focal diameter. In all situations, focal diameter between this point and this point. It's the line that goes through the focus perpendicular to the axis. Same thing here. This, between this point and this point, is the focal diameter. Special about it,
Why is it important to know a focal diameter?
because of the properties of the parabola. Very good question. So here are the applications. I was going to point this out to you on page 729. Parabolas have an important property that makes them useful as reflectors for lamps and telescopes. Light from a source placed at the focus of the surface with parabolic cross-section will be reflected in such a way that it travels parallel to the axis. See? If the light is right in here. As a parabolic mirror reflects the light into a beam of parallel rays. Okay, so that's one property. Finding the focal point of a searchlight reflector. So these are very important applications in physics.
Right, probably with light and reflection.
Mhm.
Lenses and
Exactly. And the eye has this property as well. Okay, so let's look at a couple of examples with parabolas. On page 730, it's all the same idea, what we just did with the other ones.
Which page?
Page 730. Match the equation with the graphs labeled blah, blah, blah. That's one option. Although I don't really like to look at the graphs, I like to analyze. Yes?
This is a random question, so you may not know. So you know who named that line Directrix?
No, I don't. Who named the Directrix? I do
It's
not.
a random question. The only reason I thought of it because I was like, well, why not name it like something else?
Nope, I don't know. But I can do some research for you if you want. So geometric definition of a parabola. A parabola is a set of points in the plane that are equidistant, which means found at the same distance, from a fixed point F called the focus and a fixed line L called the directrix. I don't know. So sorry. Okay. Are we picking?
Oh, sorry, what numbers?
We're looking at 5 through 10, 11 through 22. Exactly what we did with the ellipse and the hyperbola.
We do 6.
So also, yeah, which one?
6.
6. We'll start with 6. So here there is a parabolic reflector, and it says find the equation of the parabola. Find the diameter. Okay, the bulb is placed at the focus, and the focal diameter is 12. So here's a bulb. They're asking us to find, knowing all this information, to find the equation of the parabola. In other words, and give it to a manufacturer and say, okay, these are the dimensions. Make the satellite dish for me.
Yeah. Yeah, I'm sure probably some of these and headlights maybe. Well,
But if you discover why they called it a directrix, let me know. Thank you for asking that. Okay, you said number 6. We have y squared. Y squared equals negative 1/4 x. Okay. Match the equation, blah, blah, blah. I want to graph it. I want to find everything I can about it, and then I'll look at what they show us. Since this is a y squared equals 4px, I know for sure that this is not a function. That doesn't open upward or downward, but it opens to your right or to your left. Okay.
to the left, since it's negative.
So I have 4p.
Oh,
Definitely has to equal negative 1/4.
yeah.
So then p is indeed negative 1/16, which makes the directrix negative p, which is 1/16. So I would say it opens to your left. I don't know if you said that.
I did.
Okay.
Okay, so you're saying that 4p is the given value for that.
Yes, because I'm given y squared equals 4px. This is the equation, or this is the equation. X squared equals 4py. So now when I know, when I'm given the equation y squared equals a negative, or whatever, a number times x, I know that this must be 4p. I set equal 4p to negative 1/4. I divide both sides by 4 to get p. So remember the focus, because it opens left or right, let's say we don't know yet, it's definitely p comma 0.
What was the initial equation?
It's y squared. So this is problem 6, sorry about that, on page 730. Sorry about that. So y squared equals negative 1/4 x. Therefore, the rest is clear, I hope. Yes? Okay. So now we know that f has the coordinates negative 1/16 comma 0. Don't make me plot this. I'm just going to say it's here because I don't know how to plot negative 1/16. So I'm going to say f is here. I'm going to say definitely the vertex is 0 comma 0. There are no transformations or shifts on this. I know the directrix has to be exactly symmetric on this side. So this is the directrix. It's x equals 1/16. And now if you say graph it, I'll say, wait a minute, give me a second, because I really need to find another point. By simply having the origin, which is the vertex, it's not good enough. I'm going to say, for example, let's say x equals -4. When x is -4 times -1/4, y is 1. So again, this is my 1/16. That's horrible. So I'm going to say that this is my 4. And my -4. Because this is 1/16. I don't know where -4 is. Okay. So at -4, y squared will be 1. So y squared equals 1 when x equals -4. I take the square root plus or minus 1. So this is one point, and this is the other. Exactly when x is -4. And now I can graph. I cannot be sloppy and just say, okay, that's the vertex, and I'm done. And obviously, this is x. This is y equals 0, which is the axis of symmetry. Now I can go back to the graphs and choose the one. Obviously not, obviously not, obviously not, obviously not. So this is my only chance. Now see, I haven't looked, you picked the problem. So obviously it shows at -4 is +1 and -1. Because I can't just say, okay, let me graph it and just graph a parabola that goes through only one point that I know of. I have to create another. In this case, 2 more. Good. Do we need to choose another? We need to choose another. And I would like to look at that 53 after we finish the rest of the problems, the parabolic reflector. Okay, are we moving on to 11 through 22? Yes? Okay, any specific one? It says find the focus, Directrix, and the focal diameter, nice, of the parabola, and sketch its graph. Which one?
About 20.
We want to look at 20? The x minus 7y squared? And this is 20. Again on page 730. So again, they want the focus, the directrix. They want the focal diameter and the graph. Okay, so first I have to rearrange it. It happens that I will be writing 7y squared equals x and y squared equals 1/7 x. And again, it happens that it's, again, the x-axis is on the x-axis. Its axis of symmetry is on the x-axis because it either opens to the right or to the left. Okay, we are going to write the standard equations, y squared equals 4px. We are going to set 4p equals to 1/7, so p equals 1/28. We know now that the parabola will open in which direction if p is positive. Right. I don't know how you pick this 1/28. How do you think I'm going to plot this? I have no idea. So this is, I'm kidding, of course. So it's 1/28 comma 0. So then I know the directrix will be x equals -1/28. I know the axis of symmetry is y equals 0 for sure. I know the vertex is at the origin. right? Okay, so I have the focus that was determined. I have the directrix. Okay, I'm going to graph it, and then I'm going to find the focal diameter. Good. So I have to come up with 2 more points. I know it will open this way, but I don't know if it's going to be this way or this way. I don't know how open the parabola would be. Okay, so if I use x equals 7, it's a very good pick, because then y squared will be 1, and then I have y equals 1 and y equals -1. Again, because if this is 1 over 28, 7 will be way out of, so bear with me. I'm going to say, I don't know what to say. I don't know how far to go, really. So I'm going to say -1 and 1, which should be much bigger. Maybe -1 and -1. So something like this. You know my graph is far from being exact because of this 1 over 28 that messes me up. Okay, and finally we want to determine the length between this point and this point. Okay, so if I manage to determine this piece, then I'll multiply it by 2. Okay, so can anyone give us any information about this point? This is a point A for sure, right? Comma, when x is 1 over 28, how do I determine this? Once I have this, which is this height, then I multiply it by 2, and I have the focal diameter. So the question is, how do I get the... Say it again.
1 over 28 times 1 over 28.
So in the equation, I have to replace x by 1 over 28.
Right.
And then I will determine y. And then the answer gets multiplied by 2. And then that will be the length of the focal diameter. Okay. So when x equals 1 over 28, y squared equals 1 over 7 times 28, which I like because it's 7 times 4, and I can take the square root. So then y will be plus or minus 1 over 14. Because I have 7, 7. When I take the square root of 49 is 7. And then from here I have a 4. When I take the square root of 4, I get 2. So therefore, I know that the focal diameter will be twice times 1 over 14. So the length of the focal diameter is 1 over 7. Any questions? Any questions for me? Okay, so let's choose another, or move on to 29 through 40. And then I'd like to look at the parabolic reflector application.
So is the focal diameter, if you end up with y squared equals 1/7 x, the focal diameter was 1/7.
Yes,
Yeah.
because I have this piece multiplied by 2.
Is there a relation between the focal diameter P
And 4p.
or, yeah?
For the focal diameter?
Yeah, because the focal diameter is the same as 4p.
4P, yeah.
Right.
Is that always?
So is that a problem?
Yeah, let's look at another problem before I say anything. I don't want to say
That was
something.
the same thing.
I have-
We saw it when 7.4 earlier in the problem.
I just never thought of it. So the focal diameter Yes, the absolute value for P, yes.
Okay.
Always.
Alright.
So the focal diameter is the absolute value of 4P.
Where we at it.
Yes. Very good. So which problem are we working on before the parabolic reflector? Which one?
What number are we looking at?
We're looking either back at 11 to 22 if you need more examples, or 29 through 40. And we also have 41 through 50. Which one? 30, 30 what? I didn't hear what you said.
34.
Okay, very good. I just didn't hear. Sorry.
No, I was curious if it's 34, 36, but it should be fine either way.
Okay, 34 on page 731. And we have y equals 6. And that's the directrix. Very good. We are asked to find an equation for the parabola that has its vertex at the origin, v0, 0, and satisfies a given condition or conditions. Good. So let's look at what can happen here. The directrix is y equals 6. 2, 4, 6, which means this.
So
This is what?
-6 or 0, -6.
So the focus, very good. So the focus is 0, -6. Okay. Obviously, we know that in this situation, we are facing x squared equals 4py, because this is a function. Okay, so the parabola will open downward. I have p, which is -6. So then this is x squared equals -24y. Okay, let's look at 41 through 50, and then the parabolic reflector. Any problem?
So, what
Yes?
would be, just a quick question. Would we
Yes.
put it in that form, or would we put it in the standard form?
This is the standard form for a parabola opening downward.
Well, I'm saying instead of making it y equals x squared plus 4.
You want to make it y equals x squared over 4p. You cannot separate and say plus or minus. This is multiplied.
Okay.
So you could divide by 4p,
I see.
but this is the
Yeah,
equation.
sorry, it's times. Okay.
Yes,
We
it's
divide
multiplied.
that by-
Multiply by y.
Yeah.
Very good. Yes, Nico, go ahead.
No, I'm just
Okay,
taking it in.
41 through 50. So let's look at a problem and then look at the parabolic reflector. Which one?
47.
47. Let's take a look. 47, where are you, 47? I see it. So we have a graph. It says find an equation of the parabola whose graph is shown. Okay. And here's the graph. Obviously, this is the origin. So that's the vertex. Y equals 0 is the axis of symmetry. And it passes through 4, -2. If the parabola opens this way, obviously I have to have something that is not a function, which is 4px.
So we can just plug the coordinates into that and find p.
Exactly. That's it. So what will be the equation then, knowing this point?
4 equals 4p, so 16p.
So P equals
1/4.
correct. So then I have y squared equals 4 times 1/4 is 1x. So this is the equation of the parabola, opening to the right, going through the vertex at the origin. We were not asked to find anything else, just find the equation. So we did. Okay, last one here, 53, unless you decide that we need more. 53, so I'm copying the parabolic reflector. Any questions? Paul, any questions? Go ahead. Sorry, I don't mean to rush.
I'm just thinking.
Okay, if you notice something, we can go back.
That's the final equation, y squared is equal to x.
That's it.
Is that because when you plug 1/4 back into 4p, 4 becomes 1? Yeah.
And when you plug in the point, it has to work as well. Okay, a lamp with a parabolic reflector is shown in the figure. Okay, so I'm going to copy it. Okay, the bulb is placed at the focus and the focal diameter is 12 centimeters. Part A, find the equation. Part B, find the diameter DC, D of the opening 20 centimeters from the vertex. Bless you. Okay.
So we have a Directrix. The line between the point on the parabola and the Directrix is the same as 6 centimeters. And if it goes through 0, then
So if this is 0, yes.
then we can find out the coordinates on the parabola.
So this is a y squared equals 4px situation because it's not a function and y squared means not a function. Okay. Then we know
The line going from point A to the Directrix is going to be 6 centimeters.
so this
All the way to the Directrix, which is going to be even on the other side. Since that's 6, then it has to be a 3 for x.
how do we know that? So the focal diameter is 12p. Is 12, right? So we know that is 4p.
Yeah.
Okay, indeed, 12 equals 4p. So then p equals 3. So obviously this portion is 3. And therefore, I don't know if I need it or not. I will see in a moment. That will be 17. And this will be 3 as well. And this will be x equals -3. So far, so good?
Yeah.
Okay, so then if I have p, then I have y squared equals 12x. This is it. This is the equation of the parabola. Agreed?
Okay.
Perfect. So now we are asked to determine this distance.
Where did the 17 come from?
Because this is 20. So if this is 3, this is 17. Because we have the whole thing 20. I may not need it. So in part B, I'm asked to find the distance or the measure of the diameter between C and D. C, and D. Okay. So I need to determine this piece, and I will definitely multiply by 2 because the parabola is a symmetric figure. So I know that this is found exactly 20 units away. I have the equation. So x equals 20 centimeters. So then y squared equals 12 times 20, 240. And then I will be able to determine this piece as being the square root of 240. So then the diameter C comma D is definitely twice the square root of 240. Is that clear? Is that clear? So we determined the equation of the parabola, and we plugged in 20 to determine this height.
Right.
So 20 times 12 is 240. So y squared equals 240, which makes this piece the square root of 240, which makes this piece twice the square root of 240. And I should simplify the square root of 240. What is this? Is it 4 times 60? So it's, and then 60 will be 4 times 15. So 4 times 2. So to be exact, will be 8 to the square root of 15. But if you want, you can approximate it. So the exact is 8 to the square root of 15 centimeters, completely simplified. But if you want to approximate it, you can. Any questions? Any questions?
Thank you.
Last section here is 11.4. Shifted conic sections. Exactly what we just did, the circle, the parabola, the hyperbola, and the ellipse, but shifted. However, this chapter doesn't have anything to do about the circle, but we already did the circle. I don't request you to memorize this, but let's just read it. We don't really need it. I'd like to read it because I want you to know it's there, but there is no need for it. And I'll show you why there is no need for it. It says, general equation of a shifted conic, the graph of the equation, blah, 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 where A and C are not both 0, is a conic or a degenerate conic, which could be a point. Say it again.
What page are you on?
754. In the non-degenerate case, the graph is a parabola if A or C is 0, an ellipse if A and C have the same sign, or a circle if A equals C. It's a hyperbola if A and C have opposite signs. There is no need for this. Yes, you can look at it. No, you don't have to memorize it. So you'll see it's much easier than that. Okay, we are on page 756. Please choose anything you want from 23 through 34. 756. We are only in this section, we're only trying to identify what type of conic section that is and write the equation. So let's read the question. Mouthful. Complete the square to determine whether the equation represents an ellipse, a parabola, a hyperbola, or a degenerate conic. If the graph is an ellipse, find the centered foci, vertices, and length of the major and minor axis. If a parabola, find the vertex, focus, and directrix. If a hyperbola, find the center, foci, vertices, and asymptotes. Then sketch the graph of the equation. If the equation has no graph, explain why. 23 through 34. Anything you want.
26.
Let's start with 26. 26. Very good. X squared plus 6x plus 12y plus 9 equals 0. Can anyone give us an idea of what, before we even work on this, what could it be? It only has x squared. It does not have y squared. And if it doesn't have y squared, it cannot be an ellipse, and it cannot be a hyperbola. So what can it be?
Parabola.
A parabola. Okay? It cannot be a circle for the same reason. It doesn't have y squared. Okay, very good. So there is no square that I have to complete for y. But there is a square that I have to complete for x squared and 6x. So the middle coefficient is 6. I divide it by 2. I square it, and here it is. So these three are here. And then I move 12y to the other side. So what is inside? That's it. So remember the equation, the standard equation with no shifts up and down, left, right, whatever, is this. Oops. Right? So obviously 4p equals negative 12. Obviously p equals negative 3. Because it's x squared, how does it open?
Down.
Because this is negative, yes, it opens downward, very good. And where is its center?
To the left 3.
So left 3, so the center will be negative 3.
0.
Let's see if it works.
Yeah.
If I plug in this point, the point has to verify the equation. Otherwise, it's wrong. But yes, of course it's true. So negative 3 plus 3 is 0. This side is 0. And when I plug in 0 here, this side is 0. Good. Okay, next one. Do I get to choose, or you choose next?
Your choice this time.
Okay, I want to choose 33 or 34. Please choose. 34 it is. X squared plus 4y squared plus 20x minus 40y plus 300 equals 0. One thing is certain. This will not be what?
Parabola.
Yes, because the parabola cannot have x squared and y squared. So it can be a circle, however, because the circle was presented in chapter 1, it's not going to be a circle here. So it can be an ellipse or a hyperbola or none of the above. Okay, so first I'm looking to complete the square with x. So 20 divided by 2 is 10. 10 squared is?
100.
I have to add 100 to both sides. So now these three are here. Here where? What is in there? Very good. So that is done. Now, I have a big problem here. I have this and I have this. I have to factor out 4. I cannot divide by 4 in this particular case because if I divide everything and I mess up the whole thing. I have to factor out 4. I have to write in parentheses 40 minus 10y, 4y squared minus 40y, plus something minus something. And I have to move 300 to the other side. And I get for now negative 200. So one more time. These 3 are accounted for. They're here. Then these 2 terms, I factor out 4. 4y squared minus 40y. I have to add and subtract inside parentheses now. Not inside the parenthesis and outside on the other side. No, I cannot do that. It has to be inside. And this number has to cancel this number. In other words, I'm allowed to add a 0 anywhere I want, in any form. So 10 divided by 2 is 5, and 5 squared is 25. So inside, I'm adding a 25, and I'm subtracting a 25, which means nothing. I'm not doing anything. So if I give you $25 and I take it back, there is no deal.
Right.
So now I have to complete this square, and then I will distribute outside and outside. So then what I have is x plus 10, everything squared, plus 4. So the right-hand side is negative 200. So now what do I have inside? I still have not distributed the 4 yet. So I have 1, 2, 3 terms, and then minus 25. I want these 3 terms here. Now I have to multiply the squared, nothing, just put the 4 outside, x plus 10, everything squared, plus 4, y minus 5 squared, minus 100 equals negative 200. So then I have x plus 10, everything squared, plus 4, y minus 5 squared. I'm adding 100 to both sides. So, what do we conclude? After completing the square, we know for sure that this cannot be a circle. There is no circle with a 4 up here. It has to be clean, 1 and 1. We know it cannot be a parabola. And there are 2 possibilities. One is the ellipse, and the other one is the hyperbola. The hyperbola requires one of these 2 to be negative, and this to be 1. If I divide both sides by negative 100, both of them will be negative.
Right.
So it cannot be a hyperbola. Again, the ellipse requires this to be 1, but once I divide both sides by negative 100, the left-hand side will become both terms will be negative. That's not an ellipse. So we're going to say it's not a conic section. It cannot have a negative on one side and both positive on the left. Good.
But
So
you
let's,
have a positive and a negative.
yes, yes. As long as I can make this into a 1, and 1 is positive and 1 is negative, would have been a hyperbola. Let's also look at 34. In 34 we have x squared plus 4y squared plus 20x. I'm sorry?
We just did 34. Yeah.
Oh, 33. I meant to write. Oh, I was copying again.
Yeah.
Sorry. I meant 33. So 3x squared plus 4y squared minus 6x minus 24y and plus 39 equals 0. what cannot this be?
Parabola.
Yes, definitely cannot be a parabola. Parabola cannot have x squared and y squared. And it cannot be a circle only because the circle, for some reason, they didn't want to put it together. Good, perfect. Okay, so I'm looking at x. What do I have to do first?
Leading coefficient of 1.
Yes, I cannot divide. I have to just pull it out. X squared minus 2x. Inside parentheses, I have to add and subtract. We can come back to it. And then I have positive 4, and I have y squared minus 6y, positive and negative inside. And then plus 39 equals 0. So I didn't do anything. All I did was I took 3x squared and 6x. I pulled out a 3, x squared minus 2x. I'm waiting for a number to add and subtract, which will be 0. Then I have 4. 6 times 4, 24.
You went Luke 39 over to.
You can, yes, of course. From the beginning, you can do that. Very good. So now the question is, what do I need here and subtract? And what do I need here and subtract?
2.
Okay, negative 2 divided by 2,
Oh, 1.
1. 1 squared is?
Oh, 1.
Good.
Oh, squared.
So negative 6 divided by 2 is negative 3.
3 squared is
9.
So you understand that adding 1 and subtracting 1 did not change the problem,
Right.
because this is 0. Just that now I will rearrange everything, all terms, the way I want them to be arranged, right? So I have the 3, and inside brackets now, this is what? All these 3.
X minus 1.
X minus 1, everything squared. Then I have to copy minus 1, close, plus 4. Now, what do we have in parentheses? And yes, we can move the 39 to the other side.
X minus
Y minus 3, very good, squared, and minus 9. Now I have to remove the brackets slowly. What do I write when I remove the brackets now?
3. X minus 1 squared. Minus 3.
Very good. 3x minus 1 squared minus 3 plus 4
minus 3 squared.
minus 3 squared minus 36 equals negative 39. Indeed. So it's shaping up into something, I hope. So 3x minus 1 squared plus 4 y minus 3 squared. And now I have a negative 3 minus 36, and that will be 39. Ooh, I get a 0. Because this is negative 39 and this is negative 39, 0. Not a conic, just a point. When x is 1, y is 3. This is the only point that gives us 0 there. So this whole equation is really nothing, just a point, 1, 3. It's the only solution. When x is 1 and y, because when I add 2 positive numbers to get 0, both of them have to be 0. There is no other way. So this is just a point, and the point is 1, 3. Who cares? Okay, so let's look at 27.